This tree was an integral part of our society and our environment in America in the 18 and 1900s. It was one in every 4 trees in the dominant canopy of the eastern deciduous forest was an American chestnut.
Light was brought over with the Chinese chestnuts in the late 1800s, early 1900s. It was brought into New York Botanical Garden, and they didn't know about it at the time, and it got loose, and it attacked the American chestnuts in the area, and because it was airborne and able to travel so easily, it went up and down the Appalachian region, devastating the American chestnuts. But we brought it over here, so we need to do something about it. American chestnut was historically important to the Appalachian region, both as a food source for people and for wildlife, as well as a source of economic material, such as lumber. It's very rot-resistant lumber, and because the tree is so straight, you can make longer poles than you could with another tree.
In Appalachia, one of the ways that the American chestnut tree was used and was timber production. And you wouldn't necessarily have to go out and cut a whole swath of trees because they were so big and so tall and so wide around that, you know, one tree would fill up a rail car. I am sitting on, and these are all older chestnut tree stumps, and we like to keep them here just as a reminder that the chestnut tree, you know, has a future and had a majestic past.
The Chestnut Foundation's backcross breeding program focuses on using Chinese ancestry to get disease resistance sources. The initial process would involve crossing a Chinese with an American tree or an American tree to a Chinese. Create a hybrid. It's called an F1. That's about half and half. You grow those trees for a period of 6 or 8 years until they're fairly large, and then you can pick the ones that have the best characteristics that you want for resistance. The first backcross would be the product of crossing that F1 to a pure American, a different pure American that's not related to the first one. And when you make that cross, you get what's called a backcross 1. So now you have a tree that's 75% American and 25% Chinese. And because you looked for the ones that had the best disease resistance in the F1 stage, you should get a small percentage in this backcross 1 generation as well that have some resistance to the disease. You give them the disease, and if they respond fairly well, you pick the best of those in the backcross generation, and you make a second backcross by crossing to another American parent. So then you get a product that's on average 87.5% American and still has some Chinese, but each generation, so you're kind of diluting the Chinese but keeping the part of the Chinese genome that you want, which will confer resistance to the disease. You select the best trees by introducing the infection to the tree itself. That's called inoculation.
And in between every generation, we test the trees for their resistance from the blight. We do that by inoculating the tree with the chestnut blight, Cryphonectria parasitica. We bore a little hole into the tree. We put a plug of the blight fungus. We'll select for their resistance, and if their American character is good enough, then we'll push those on in the breeding program. So this tree actually scored the highest out of all our trees here in the orchard. For resistance, you can see the 2 inoculation points here and here. The upper inoculation point is the weaker strain of the blight fungus, so you can see that it's got a smaller impact on the tree. And this is the stronger strain, but both of these sites are looking very good for a backcross tree. You know, the tree has walled off the infection. You don't see a lot of the sporulation of the canker spreading or breaking out of that defense. So this is a very nice reaction. Down below you can see this bulging and splitting. That's actually a natural basal canker. So this is an example of a less ideal inoculation reaction. This isn't the worst of the worst because those have actually already been culled out of this orchard. But you can see the weaker strain of the blight fungus that we put in here. And you can see this canker is spreading quite far beyond the tree's response. It's trying to wall it off, but the blight fungus is well outpacing this reaction. Again, down here, this basal canker, a lot of splitting. You can actually see that it's exposed part of the wood here. and the tree is sending up these sprouts because it knows that it's dying. You know, a lot of folks think that an easier solution would just be to replace the American chestnut with Chinese chestnut or Japanese chestnut. However, the growth characteristics of those trees, those Asian species, are different. It maxes out at about 60 feet tall, whereas the American is 80 to 100 feet tall. The Chinese chestnut tree basically just couldn't cut it out on the landscape. It can't compete with the fierce environment that we have in our native hardwoods. They basically would just get shaded out by other trees. So it's very rare to find a Chinese chestnut in the native forest. They just don't have that competitive ability.
FoxHaven is helping by being a partner, providing a site for a large orchard. It's been there for, I think it's 8 years now.
I see good things ahead, and I am so grateful to the scientists who are working on it, and I'm really grateful to all of us who are trying to, put these orchards in place, and to the tons of volunteers who just dedicate themselves and some of their free time to maintaining those orchards and to inoculating the trees, just so that we can kind of keep the process going and trying to find a blight-resistant chestnut tree. And we're definitely dedicated to that here at FoxHaven Organic Farm. We've got 3 acres out there, and we have folks coming and going on a regular basis, trying to figure out, how we can create a positive future for the American chestnut tree. And I don't see that changing here at FoxHaven. I think that everyone's efforts in restoring the American chestnut kind of shows that we care about where we live.
We have the understanding, the technology to make it happen, and it's just a beautiful tree.